Scientists just uncovered dinosaur footprints where they should have never been, and some say humans walked right beside them. Let's go to Glenrose, Texas, a sleepy town that holds one of the most puzzling stories in paleontology. Beneath the shallow waters of the Paluxy River lies a prehistoric trail that has sparked both scientific fascination and whispers of controversy. We're talking about some of the clearest dinosaur tracks ever found, pressed into limestone over 100 million years ago. But that's not the only reason this site has drawn international attention. Back in the 1930s, people started noticing something strange. Right alongside those three-toed dinosaur prints, likely left by a carnivorous theropod, were shapes that looked suspiciously human. Not clawed or splayed or distorted, but footprints, with heels and toes. Cue the conspiracy theories. Some swore this was proof that humans and dinosaurs walked the earth together. Others claimed it was a hoax, erosion, or misidentification. To this day, the debate pops up in documentaries and online forums. And while science has moved on to more grounded explanations, like overlapping prints and the quirks of sediment, that mystery still hangs in the air like Texas heat. It's a time capsule. The tracks don't just show us who was here, they show us how they moved. You can trace the steps of a predator chasing prey, or a herd sticking close in what was once a muddy riverbed. Some prints are deep and crisp, while others barely mark the surface, clues to weight, speed, and direction. It's not just science, it's storytelling carved into stone. The Paluxy tracks even helped researchers rethink how some dinosaurs walked. The spacing and toe angles suggest surprising agility, especially for species we once thought of as lumbering. They weren't just big, they were fast, alert, and alive in ways we're still piecing together. So, were there really human tracks? Probably not. But what is real are the prints of creatures that ruled this land long before us, frozen mid-stride like a Polaroid from another world, and in a way that's even more thrilling. From the muddy plains of Texas we move west into Utah, where things get sharper, leaner, and a little more dangerous. At first glance, the dinosaur tracks found here might look ordinary, even crude. But follow their rhythm, the spacing, the depth, and suddenly, a picture forms. This wasn't some slow-moving giant, it was a predator, fast and calculated. The three-toed imprints carved into the Navajo sandstone belonged to a large theropod, likely a megalosaur or a closely related carnivore. Each step stretches several feet apart with claw marks at the tips as if frozen in the act of pursuit. These tracks aren't scattered randomly. They follow a pattern, like a stalker following something unseen, maintaining a straight line with tight precision. The most intriguing part? Some prints show slight sliding in the toes, like the animal was making sharp turns or braking quickly, suggesting it was either chasing prey or dodging an obstacle. This wasn't just walking, it was a hunt. Utah has yielded hundreds of such prints in sites like Johnson Farm and Copper Ridge, but it's the details that thrill scientists. Impressions left behind by pads, scrapes in the rock suggesting tail brushes, and even pressure deformations beneath the footprint that reveal muscle weight and movement. That's the kind of data no fossil skeleton can provide. It's one thing to know what a dinosaur looked like, it's another to know how it moved through its world. These prints suggest that the predators of Jurassic Utah were highly mobile, surprisingly agile, and perhaps most fascinating of all, strategic in how they moved through space. You're not just looking at feet in rock, you're looking at a decision frozen in time. Utah's sharp prints fade into the soft riverbeds of Glenrose, Texas again. But this time, we focus on a site that's more complete, more varied, and deeply revealing. The tracks found here aren't just numerous, they're layered like a prehistoric traffic report. There are paths of massive sauropods wading through mud, smaller theropods darting between them, an occasional overlap that tells us something remarkable. Different species were moving through the same place at the same time. These prints date back 113 million years, preserved in what used to be the silty banks of a shallow tropical lagoon. Unlike many fossil sites that are interrupted by time or erosion, Glenrose offers continuous trackways, trails that stretch for over 100 feet without a break. That kind of preservation gives researchers something rare, a multi-minute snapshot, not just a footprint. Some sauropod prints here are over 3 feet across, but even more fascinating are the subtle details. You can see the squish of the heel, the drag of the toes, and even the shifting of the animal's weight as it moved. And then, crisscrossing those massive impressions are much smaller, sharper prints, perhaps from a predatory dinosaur tailing the herd from a distance, careful not to be seen. The tension between predator and prey is locked into the sediment. Even the depth of the footprints tells us more than expected. Deeper impressions often correlate with wetter ground, and by analyzing the soil layers, scientists have pieced together the likely season, weather, and even the dinosaur's speed. These aren't just prints. They're a prehistoric footprint logbook, and every detail pushes us closer to understanding how dinosaurs really lived, not just how they died. Next, we head south, way south, to Bolivia, where something massive left its mark high on a cliffside. What kind of animal could leave a single footprint the size of a bathtub? Let's find out. Tucked into the cliffs near Sucre, Bolivia, lies a wall that seems ordinary, until you step closer. Then suddenly, you realize it's not a wall at all. It's a vertical canvas of history, nearly 300 feet tall and stretching more than a quarter mile. This is Cal Orco, one of the most impressive fossil track sites ever uncovered, and somewhere on this slope lies something that still leaves scientists speechless. A dinosaur footprint measuring over 3 feet wide, the largest of its kind ever recorded. This print likely belonged to a titanosaur, one of the biggest animals to ever walk the earth. But what makes it even more jaw-dropping is where it was found, embedded in a near-vertical slab of limestone. Of course, when the tracks were made, the ground was flat. Millions of years of tectonic activity slowly pushed the slab upward, preserving these steps at an angle that now towers over visitors. It's like time itself got tilted. The track isn't alone. Over 12,000 individual footprints have been documented at Cal Orco from at least 8 different species. What makes this site especially valuable is its density. Some areas show over 500 steps in one sequence, providing clear evidence of how these animals moved, turned, and even traveled in groups. And that giant titanosaur print, it's not a one-off. The same individual may have left an entire trail, tracing a long, slow journey across soft ground that hardened like concrete under ancient sun. Paleontologists analyze not only the shape but the spacing of the prints. A stride this long suggests a creature over 80 feet in length, possibly weighing close to 50 tons. But it wasn't just big, it was steady. The depth of the impressions suggests this dinosaur walked with careful, deliberate steps, avoiding slipping on the wet clay. It wasn't crashing through the landscape, it was floating across it. From towering cliffs to sudden floods, dinosaur footprints are often revealed when nature peels back the layers, and that's exactly what happened in Australia. In Western Australia's Kimberley region, the red earth tells stories, but only when it's ready. For decades, rumors circled about dinosaur tracks hidden in the remote coastal sandstone near Broome. Locals knew they existed, but for most of the year, they were submerged beneath the tides. Then came a period of extreme drought. As the waters pulled back, so did the curtain on what scientists now call one of the most diverse dinosaur track sites in the world. Stretched across miles of rock are at least 21 distinct types of footprints, left behind by everything from giant, long-necked sauropods to swift bird-like carnivores. Some of the prints are tiny, no bigger than a dinner plate, while others are massive, nearly as wide as a truck tire. The sheer variety of track shapes, sizes, and walking styles led researchers to nickname the area Australia's Jurassic Park. Unlike other track sites, these prints are preserved in ancient tidal flats where dinosaurs likely passed during migration or while foraging near shallow waters. The sediment here is soft enough to record details, toe claws, pad wrinkles, and even skin impressions, yet hard enough to preserve them for over 130 million years. It's a rare balance. One of the standout discoveries was a perfectly preserved sauropod trackway that stretches over 150 feet, with each step showing slight differences in angle and depth. This gave scientists rare insight into how the creature shifted its weight while walking, adjusting to the slippery surface beneath its feet. What's even more exciting is that this entire site was nearly lost, not to erosion, but to industrial development. Plans to build a natural gas hub nearby almost wiped out the trackways before they were fully studied. A last-minute intervention preserved the region, turning it into a protected site and giving the world a chance to see Australia's long-lost giants, step by step. And next we're off to Wales, where erosion didn't bury the past, it uncovered it, revealing dinosaur footprints on a beach that was never meant to be walked by humans. Not all fossil finds happen deep in deserts or high on cliffs. Sometimes they appear where you'd least expect, like under your feet during a walk on the beach. That's exactly what happened in Wales, along the coast near Penarth. After a series of strong tides and storms shifted layers of coastal sediment, a series of three-toed dinosaur footprints appeared on the rocks, delicate, crisp, and ancient. These tracks had been resting just beneath the surface for more than 200 million years. What's unique about these Welsh footprints isn't just their age, though they do date back to the early Jurassic. It's their setting. The impressions lie scattered across a tidal zone, meaning they're frequently submerged and then re-exposed, a cycle that paradoxically erodes and reveals at the same time. When visible, the prints offer rare evidence of early, small-bodied bipedal dinosaurs, possibly related to Coelophysis, moving quickly along muddy terrain. Many of the footprints appear grouped, hinting at behavior, maybe a small pack traveling together. Others overlap at strange angles, as if different individuals crossed the same ground hours or days apart. These aren't the tracks of slow giants but of quick, agile animals navigating a shoreline that looked very different from today. Scientists speculate they might have been hunting or even following retreating water to feed. The location also brings a strange sense of time travel. On a good day, beachgoers and fossil hunters now walk the same stretch of Earth that dinosaurs once paced in moonlight. Some locals even refer to them as ghost steps, and there's something oddly fitting about that. Ancient life, revealed only when the sea chooses to give up its secrets. But for a real contrast, we now head from the warm Welsh coast to the cold volcanic wilds of Alaska, where tracks are found not in sand or mud, but in ancient ash. Alaska isn't usually the first place that comes to mind when thinking of dinosaurs, but fossilized footprints found in the remote Aniakchak caldera challenge that idea completely. Located in a vast, rarely visited stretch of wilderness, this ancient volcanic basin was once the stage for a different kind of drama. Dinosaurs walking through freshly fallen ash near the edge of a long-extinct volcano. The most remarkable tracks found here belong to hadrosaurs, also known as duck-billed dinosaurs. The prints are deeply impressed in layers of compacted ash and fine sediment, remnants of volcanic events that took place over 70 million years ago. These weren't isolated steps either. Some trackways stretch for nearly 200 feet, winding across open ground that would have looked eerily empty and quiet. The environment was harsh, even then. Analysis of pollen and rock layers shows signs of a cold, wet climate, possibly bordering on what we'd now consider subarctic. That makes these prints especially valuable, showing that dinosaurs weren't just creatures of jungles and swamps. They adapted, they traveled. Some may have even migrated seasonally through colder regions, using paths like this one carved into volcanic ground. Interestingly, some of the footprints show signs of slippage, suggesting the ash may have still been loose or hot when the animals walked over it. This implies a narrow window, a perfect moment when geology and biology collided. If the ash had cooled too much, it wouldn't have preserved the prints. If the dinosaurs had arrived earlier, the surface may have been too unstable to hold a shape. The result? A prehistoric snapshot, unlike any other. And speaking of snapshots, China holds something far more crowded. A place where over 300 prints tell an entire story in one spot. In China's Sichuan province, an ancient riverbed turned stone holds one of the world's most extraordinary collections of dinosaur footprints. Locals call it a dance floor, and once you see it, it's easy to understand why. More than 300 distinct tracks are spread across a single sediment surface, crisscrossing in every direction, like rush hour traffic frozen in time. Discovered in recent years, this site is a treasure trove for scientists. The footprints range from small bird-like imprints to massive oval depressions made by long-necked sauropods. What's fascinating is the density, no long trails, just a concentrated area where dozens of animals were clearly walking, turning, and interacting in close proximity. This wasn't a migration path, it was more like a congregation point. Some paleontologists believe this may have been a social area, possibly a watering hole or a floodplain where herds gathered and predators lingered nearby. The overlapping tracks suggest a dynamic scene, large plant eaters trudging through sticky mud, lighter predators zipping between them, and juvenile dinosaurs following adults with shorter, hesitant steps. Even more impressive, the site preserves extremely fine details, including toe pads and claw scrapes. This allows scientists to distinguish between individuals of the same species, sometimes tracking how one specific dinosaur looped around and passed the same point more than once, a prehistoric version of pacing. Beyond science, there's a strange beauty to the place. Hundreds of lives intersecting on one patch of land, leaving behind a record not in words or bones, but in the subtle pressure of feet in mud. No wonder locals gave it such a poetic name. In Patagonia, the wind sweeps across dry hills and scrubland, but beneath the dust lies a scene frozen in the soft mud of the Cretaceous period. A place where giants and hunters once crossed the same patch of earth, within hours or even minutes of one another. Paleontologists uncovered a remarkable track site in La Rioja province that captured two very different stories at once. The steady, deep prints of a sauropod moving slowly across the ground, and just off to the side, smaller, sharper prints from a carnivorous theropod. These aren't speculative trails. The sauropod left behind a clear series of four-limbed impressions, massive and rounded, spaced far apart. Each step a testament to its scale. But the theropod's prints are narrow and three-toed, with claw marks digging into the edges, hinting at quick turns and sudden stops. The predator's path doesn't intersect directly, but it skirts close, curving around and following the same general direction. What does that mean? Some researchers believe this was more than coincidence. The spacing of the theropod prints suggests it was tracking, staying behind, perhaps keeping the sauropod in view. This wasn't an ambush, not yet, but it was close. The mud was thick enough to capture weight shifts, and in some prints the heel impressions deepen, showing where a dinosaur leaned or stumbled slightly. Even tail drag marks appear in the sediment, rare and precious clues to posture. It's like a chase scene paused mid-action. There's no sign of a struggle, no sudden chaos in the footprints, just quiet, eerie parallel lines etched into the ground. Predator and prey walking the same road, both unaware that their journey would outlast them by millions of years. In central India, near the town of Jabalpur, the ground tells a stranger story. One where fire and footsteps met. Long before the Deccan Traps became one of the largest volcanic provinces on Earth, this landscape was a shifting patchwork of forests, rivers, and lava flows. And at least once, just after a volcanic event cooled the Earth, a group of dinosaurs walked across a fresh bed of still warm ash. These tracks, now hardened into basalt-like rock, are among the few examples in the world where dinosaur footprints were preserved in volcanic material. Most fossils are found in sediment or mudstone, soft surfaces that compress and solidify over time. But here the dinosaurs left their marks in ash so fresh it was still pliable, yet firm enough to hold their shape. The best-known prints in this region come from both herbivorous and carnivorous dinosaurs. Some are wide and flat, with rounded toes, likely made by a group of titanosaurs. Others are narrow and more angular, left by theropods walking across the same surface shortly after. What's fascinating is that the prints suggest almost casual movement. No signs of panic, no sudden directional changes. It's as if the dinosaurs were completely unfazed by the recent volcanic activity. Scientists believe the lava had cooled just enough not to burn, but was still soft enough to take impressions. The equivalent of walking across freshly poured concrete. That balance had to last only a few hours, maybe even minutes. A slight shift in temperature and the prints would have disappeared forever. Today these fossils are baked into dark, almost black stone, creating a surreal contrast. Life preserved by the very force that usually destroys it. Fire didn't erase their steps, it immortalized them. On the Isle of Skye, where the cliffs rise into mist and ocean wind cuts through prehistoric stone, dinosaur tracks tell a story few people expected from this northern outpost. Known for its rugged beauty and Celtic legends, Skye also holds one of the UK's most significant Jurassic track sites, a place where sauropods and theropods once wandered together along tidal flats. The discovery wasn't dramatic at first. A paleontologist stumbled on the prints during low tide, where erosion had peeled back a rock layer to reveal massive, rounded footprints, each about 2 feet across, arranged in loose, meandering trails. These were the steps of long-necked giants walking along the edge of a lagoon, possibly searching for food among mangroves and shallow water. What made the find more exciting was the presence of smaller, three-toed prints nearby. They weren't random, they moved in different directions, cutting between sauropod paths or curving back on themselves. Scientists quickly realized this was a rare snapshot of cohabitation. Two types of dinosaurs sharing the same ecosystem, moving across the same terrain. The track site also holds fine sedimentary layers, allowing for detailed analysis of the foot anatomy. Some of the impressions show skin textures, tiny bumps and ridges that hint at the animal's scale pattern. Others reveal how the foot sank unevenly, suggesting the ground was wet and squishy underfoot. Even more, the geology around the site paints a vivid picture of the time, a subtropical shoreline with volcanoes nearby, lush plant life and rising tides. The ocean was close and danger may have been even closer. Yet these tracks speak of routine, creatures going about their day unaware they were leaving a permanent record behind. Bones show us the frame, but tracks show us the performance. They tell us what the dinosaur was doing, where it was going, how fast it moved, and whether it was alone or not. Footprints are not just leftovers, they're motion captured in stone, the closest thing we have to a living moment from millions of years ago. In some ways, tracks are more honest than fossils. A skeleton can be transported, crushed, jumbled, but a footprint stays exactly where it was made. It's not just what the dinosaur was, it's where it lived, what the terrain was like, even what the weather might have been that day. A shallow print in dry clay tells a different story than a deep one in wet mud. A narrow trail means something very different from a scatter of random steps. At sites like those in Texas, Bolivia, and China, the value of tracks goes far beyond just mapping movement. Scientists have used them to estimate body mass, reconstruct stride lengths, even detect limps or injuries. Some trackways show adults followed by smaller prints, likely juveniles, hinting at family behavior. In one case, tail drag suggested resting, while uneven depth pointed to stress or fleeing. Every detail is a clue. And let's be honest, there's something visceral about standing next to one. You don't just see the trace, you feel it. A footprint sunk into stone says, "I was here." No bones needed. In a world where we chase ancient life through fragmented skulls and fossil shards, these steps feel more immediate. They aren't silent like skeletons, they speak, they move, they go somewhere. They show us that the earth once pulsed beneath creatures whose weight shaped the very ground. And now, millions of years later, we follow their paths, not just to know them but to understand the world they left behind. Not frozen, not extinct, just paused, waiting to be read. That's about it. Which dinosaur is your favorite? Write in the comments. For more useful information, watch other videos.